A very good morning to all. MCGM Education Department, Goregaon MPS Municipal Secondary School East. So today I'm going to continue with my topic of chemical reactions and equations. So let's continue with our topic. So yesterday we have seen about the corrosion, and today we are going to see about what you mean by the rancidity. Now, what do you mean by rancidity? Rancidity means when we use old leftover cooking oil for making any foodstuff. So it is found to have a foul odor, and that particular odor which comes when we use this leftover cooking oil, so that is known as the rancidity. So you can call that rancidity is the development of an unpleasant smells in fats and oils which are often accompanied by changes in their texture and appearance. So there are two types of rancidity. First is the hydrolytic rancidity and then is the oxidative rancidity. So here we will see one by one. So first of all, let's elaborate the topic of rancidity. That what do you mean by the rancidity? Now here in this case, if the food is cooked in such oil, that is the oil, the cooking oil which was left over for making the food stuff, so its taste it changes, right? Isn't it? You might have seen that. You might have observed that. So when the oil or a ghee is left aside for a long period of time, or fried food is left aside for a long period of time, it undergoes air oxidation and thus it becomes rancid. So rancidity is in the foodstuff cooked in oil or ghee is prevented by using the antioxidants. Okay, it can be preserved. So it can be prevented by using some of the antioxidant, which will not allow the oxidation of that oil. So here the process of oxidation reaction of foodstuff can also be slowed down by storing it in an airtight container. Okay, these are all the things about the rancidity. So rancidity means what? When the leftover cooking oil for making foodstuff is found to have a foul odor. So when we use it, it taste changes. Okay, so that is known as the rancidity. So here we have seen about, so now here two types of rancidity are there: hydrolytic rancidity and oxidative rancidity. So maybe the hydrolytic or the oxidative leading to the typical flavor changes of rancid oil. Okay, so maybe the hydrolytic or the oxidative. These either hydrolytic process or with the oxidative process, the typical flavor of that rancid oil may change. So all the oils, they can turn rancid. Example, maize, groundnut, sesame oil, sunflower oil, then mustard oil, all the oils, they can turn into the rancid. So changes in the flavor is typical and same for fats and oils. All the changes and changes in the flavor, that is all one and the same for all the fats and the oils. So here what do you mean by the rancidity? Rancidity is a term which is generally used to denote the condition of unpleasant odor. Okay, so whenever, while as I already told you, the leftover cooking oil, if you reuse it, that time what happens, or if you keep it for a longer time, it smells foul. That means it is an unpleasant odor. Okay, when you use the fresh oil and the used oil, so in that case both the oils will have the may have the different smells. Okay, the oil which is fresh, they will that will not have any kind of unpleasant odor, but the oil which was used and which was left over for a longer time, it will have an unpleasant odor. Why? Because of the rancidity. Okay, so these unpleasant odors and flavors in the foods resulting from the deterioration in the fats or the oil portion of a food. So this unpleasant odor and flavor in food that result into the deterioration means it deteriorates, it destructs, and it deteriorates in the fats or oil portion of that particular food. So here rancidity, it can be of many types. Rancidity can occur due to the hydrolytic rancidity. It can be an oxidative rancidity or it can be a microbial rancidity. Okay, so the maybe because of these three conditions, rancidity can occur. Anyone, either due to the oxidative, either due to the hydrolytic, or either due to the microbial. Now here you can see tomato is there, how it goes on rancid because of the oxidative rancidity. You can see the picture where a fresh tomato gets rancid, and after that see what is the condition of that particular tomato. Same way, suppose a normal cell is there, then the cell is attacked by the free radicals, and after that cell with oxidative stress, means because of the oxidative rancidity, this deterioration of the food takes place. So these are the cases. So here in short we can say that rancidity means what? In short, when we use an old leftover cooking oil for making foodstuff, it is found to have a foul smell, and it is known as the rancidity. It can be a hydrolytic rancidity, it can be a oxidative rancidity, or it can be a microbial rancidity. Any of the three. Then, if food is cooked in such oil, it takes changes. So, when the oil is left aside for a long period of time, or fried food is left aside for a long period of time, it undergoes air oxidation. So, you might have seen, suppose the thing which you have fried 2 days before, and if you keep that food for 2 days, and after that, when you smell it, it will smell bad. It will have an unpleasant odor and the flavor too. So you will not prefer to eat it. Why? Because it has become rancid. So here rancidity is nothing but the what the it is nothing but the leftover cooking oil or ghee. It can be ghee also for making the food stuff, and when it is placed for a longer period of time, that time it gives an unpleasant odor and flavors in that particular food. Okay, it is known as rancidity. Now, how we can prevent it? We can prevent it by using the antioxidant, which will not allow the oxidation of that particular food, or we can keep that particular food in an airtight container so that it will not undergo oxidation. Okay, now till this all the topic has been covered. Now we are going to see about how to name the reaction. Now in the exam mostly it has been asked different types of reaction will be given to you and how to name those particular reactions. So we will see that. Now first of all, before that, before seeing each and every reaction, first we should know different types of chemical reactions. So in short we will revise so that it will be helpful for you to name the reactions. So first is the combination reaction. Now whenever any combination reaction is there, just listen carefully. That will be helpful for you to understand which one is the reaction given. So here combination means in the combination reaction, the reactants will be two, and a combination of two reactants will give us one product. Okay, then in decomposition, which is the reverse of the combination reaction, here reactant is one and product will be two. That means breakdown of the reactant takes place. Then in displacement reaction, two types of reaction we have seen. First is the single displacement reaction, and then is the double displacement reaction. Now in single displacement reaction, you have to use the reactivity series. Okay, and a less reactive element is replaced by a highly reactive element, and it will give us the product. Okay, and in double displacement reaction you don't have to use the activity series. Okay, directly here either the exchange of cations will take place or the exchange of anions will take place. Means positive charges will exchange with each other, or negative charges will exchange with each other. Now in a displacement, especially in the single displacement reaction, the element which has to be exchanged, if it is a metal, then only a metal can replace a metal. If it is a non-metal, then only a non-metal can replace a non-metal. It will not happen that metal will replace a metal and non-metal will replace a metal. This will not happen. Metal will replace a metal only and non-metal will replace a non-metal only. Then comes the oxidation and reduction reaction, which is also known as the redox reaction. Now in oxidation reaction, what will happen there? addition of oxygen takes place, and in reduction reaction, removal of oxygen takes place. In oxidation reaction, removal of hydrogen and electrons takes place, whereas in reduction reaction, here addition of hydrogen and addition of electrons takes place. So these are all the basic uh, key which will helpful for you to understand which one is which reaction. Okay, now we will see one by one. Now name the reaction. These kind of questions can be asked in the exams and mostly asked in the exams. So listen carefully. Now first one, Mg plus O2 gives MgO. Okay. Now by seeing this reaction, first of all, we will go one by one. So we are having these 5 types of reaction with us. So among them only any one reaction it may be. Okay. First of all, we will go by the combination. Now what is the key factor for combination? That reactants are 2 and product is 1. Now here you can see Mg plus O2. Here reactants are 2 and the product which we are getting is 1. Okay. Now always remember, in a combination reaction only reactants will be 2 and product is 1. Okay. And in decomposition reaction, reactant is in a combination reaction, reactant is 2 and product is 1. Whereas decomposition is the reverse of it, where the reactant is 1 and the products are 2. Now in displacement reaction, we are getting two products, 2 reactants in the left hand side and 2 products on the right hand side. Now here in combination reaction, we are seeing what? We are seeing 2 reactants on the left hand side and 1 product. So here this is not a displacement reaction. Okay. So both the single displacement and double displacement is removed. Okay. So here you can call it as an oxidation reaction. Why? Because oxygen is added in MgO. So here we can say that it is a combination reaction. Why? Because here 2 reactants are present. Okay, Mg and O2. Here 2 reactants are present on the left hand side and we are getting only 1 product. So this is a clear solution that here it is a combination reaction. Okay, and we can call it as an oxidation reaction. Why? Because oxygen is added in Mg. So this can also be called as an oxidation reaction. Okay, only oxidation, not reduction. So here it is a combination reaction and oxidation reaction. Okay, then next comes the CO plus O2. Now here in this case, again, we will go one by one, 5 types of reaction we are having. So first of all, combination. In combination, 2 reactants and 1 product is there. So here we can also find out that here 2 reactants are there and 1 product is there. So it is a combination reaction because combining of both the reactants gives us the product. So here in this case, oxygen is also added. So we can also call it as an oxidation reaction. Okay, so here both the reactions are the combination reaction and oxidation reaction. Now, why not the displacement reaction? Because in the displacement reaction, two reactants are there on the left hand side and 2 products are there on the right hand side. But here in the combination reaction, only 2 reactants will be on the left hand side and 1 product will be there on the right hand side. So this is a clear solution that here it is a combination reaction. Now here you can see. Now let's balance it. Now you can see that here in the left hand side, now both the reactions are combination reaction. Now we will see how to balance the reaction. Now you can see that Mg is having on the reactant side, Mg number of atoms of Mg is only 1, whereas oxygen is 2. On the right hand side, Mg is 1 and oxygen is 1. Now oxygen is 1 in the product side. So we have to always remember the number of elements or atoms or molecules should be same on the left and the right hand side. Okay, so left and right hand side, both the sides should be same. Okay, so here in this case, in the product side, oxygen is less. So what we will do, we will add a 2 before Mg. Okay, because we cannot put 2 before oxygen or between the Mg and O. We have to put it before Mg. 2 we will put there, and after that what will happen after putting 2 there? Mg will also become 2. Oxygen has become 2 then Mg will also become 2. So again 2. Now here in this case you can see here as I have written. So we are adding 2 in front of Mg. So after adding that, we are getting number of molecules of Mg2. Okay, and oxygen has also become 2. So oxygen is now it is equal. But Mg on the right hand side, if it is 2, then also we have to make it 2 on the left hand side. So what I will do, I will again write 2 in front of Mg, so that number of molecules or number of atoms of the elements of Mg will become 2 and 2 on both the sides. Okay, so here you can see here number of Mg is 2 on the left hand side and oxygen is also 2. Number of Mg and oxygen is 2 on the right hand side, that is on the product side. Then again carbon, and number of carbon on the left hand side is 1 and oxygen is 3, because we are at oxygen of CO plus O2. Okay, so 1 plus 2 comes 3. So here oxygen is 3 on the reactant side, and on the product side here carbon is 1 and oxygen is 2. Now here on the left hand side, on the reactant side, oxygen is more. So what we will do, again on the right hand side we have to put number that will make the number of oxygen same. Now while putting 2 before carbon, we are making oxygen 4. So again now carbon is also becoming 2. So here what we will do, we will so here on the product side 2 is there. So again we will add 2 before the carbon monoxide, so that all the number of atoms will become same, both on the reactant side and both on the product side. So in this way only you have to make the number of molecules or number of atoms same on both the reactant and the product side. So here you can take a screenshot, so that that will be helpful for you how to balance the reaction. Okay, now next reaction. Now suppose it is given that sodium plus chlorine, it will give sodium chloride. Okay, now here in this case, which is this reaction? Okay, so here first of all we will go 5 reactions. We know it is not a, we will go from down, it is not a oxidation reaction, it is not a, sorry, it is not a displacement reaction, not a single, not a double displacement reaction, then it is not a decomposition reaction, but it is a combination reaction. Okay, why? Because 2 reactants are there on the left hand side and 1 product is there on the right hand side, and whatever product we are getting, that is the combination of both the reactants. So here it is a combination reaction. Then comes the fourth one, that is H2 plus O2 gives H2O. Now again here 2 reactants are there, 1 product is there, and by combining 2 of the reactants we are getting the product. So hence our answer is both are the combination reactions. Okay, so next we will go. So here CaCO3, okay, when heated, okay, when CaCO3 is heated, then we are getting CaO and CO2. Now in this case, we will go one by one. First is the combination reaction. Okay, whether it is a combination reaction? No, it is not. Why? Because reactant is only 1 and products are 2. Now, whenever the reactant is 1 and product is 2, then we can say surely that it is a decomposition reaction. Okay, decomposition means breakdown. So here you can see that there is a breakdown of CaCO3. So here we are getting CaO and CO2. Now here you can see in presence of heat it is written. Okay, so one type of reaction we have seen while studying this chapter, that exothermic and endothermic. When any compound it is taking the heat, it is absorbing the heat, that is a endothermic reaction, because it is an absorbing the heat. So after absorption of the heat, it breaks down into the compounds. So here you can see in presence of heat, or it is a thermal decomposition also you can say. So we can say that it is an endothermic and decomposition reaction. By decomposition reaction, because here breaking down of CaCO3 is taking place into CaO and CO2. That means here it is a decomposition reaction where reactant is 1 and the product is 2. Okay, Then comes the H2O plus CO2, and it gives H2CO3. Okay, so here in this case, we here two reactants are there and one product is there. Okay, so that means two reactants and one product. That means it is a combination reaction, because by combining two of the reactants we are getting only one product, so it is a combination reaction. Here you can see CaO CO3 in presence of heat, or in presence of thermal decomposition, where thermal decomposition of calcium carbonate takes place into calcium oxide and carbon dioxide. Then comes the H2O plus CO2, it will give H2CO3, which is a combination reaction. Now you can see the process. It is a decomposition and combination reaction, both are reverse processes of each other. So you can see here the difference. Okay. Then comes the CuSO4 plus Zn, which gives ZnSO4 plus Cu. Now first of all, first is the combination reaction. Now, whether it is a combination reaction or decomposition reaction, no, none of them. Why? Because here both the reactants are 2 and the product is also 2. Okay, number of reactants are 2 and number of products are also 2 here. So combination means 2 reactants, 1 product, and decomposition means 1 reactant and 2 product. So none of the combination and decomposition reaction are fitted here. So here 2 reactants and 2 products are there. That means it will be a displacement reaction. So now, which displacement reaction? Now, as I already told you while teaching that reactions, that whenever there is a single displacement reaction, then the reactant will have one compound and one element. Now here you can see CuSO4 is a compound and Zn is an element. That means, always remember, whenever there is a single displacement reaction, there will be always a one compound and an element. So here, this is a single displacement reaction. Why? Because here on the reactant side, there is a one compound and another is the element. If there are two compounds in the reactant side, just listen carefully. Okay, when there are two compounds on the left hand side or on the reactant side, then that will be your double displacement reaction. Okay, now see, CuSO4 plus Zn. Now here one compound and one element is present. That means it is a single displacement reaction, because as only one element is present, so obviously only one element will be replaced. Okay, so as one element will be replaced, so here it is a single displacement reaction. Okay, now Zn is a metal, so it will replace a metal, that is Cu. Now for that we should know the reactivity series, whether Zn is able to remove Cu or not, because to replace the Cu, Zn should have the high reactivity than Cu. Okay, so we will see the reactivity series here. You can see Zn is present below carbon and Cu is present below hydrogen. So that means Zn is having high reactivity than copper. Okay, zinc is having high reactivity than copper. So easily we can say that it is so here Zn can easily replace copper, and hence we are getting ZnSO4 plus Cu. So that means we can say that this is a single displacement reaction. Okay, where displacement of only metal is taking place. Now below is given AgNO3 plus NaCl, gives AgCl and NaNO3. Now first of all, it is not a combination reaction, because here both reactants and products number are 2. So here it is not a combination reaction, not a decomposition reaction. Okay, why? Because combination reaction has reactant 2 and product 1, and decomposition reaction has one reactant and 2 product. So it is not fitting here. Then comes the displacement reaction. Now, whether it is a double displacement or a single displacement. Now, single displacement reaction we have seen with the example before, CuSO4 and Zn, where one compound and one element is present. So whenever one compound, one element is present, then it is a single displacement. But here in this case, both the reactants which are present, both are compounds. Whenever in a reaction, when both are compounds, then it shows the double displacement reaction. because here exchange of either cations will take place, that means the positively charged elements, or the anions will take place, that is the negatively charged elements. So here you can see that AgNO3 plus NaCl. Now here in this case, what will happen? First they will decompose into the ions. Okay, that means Ag and NO3. Then here in the and for NaCl, Na and Cl. So then what will happen? Ag and Na will replace each other, or NO3 and Cl will replace each other. You can see in the product side, the position of the Ag and Na is same, whereas the position of NO3 and Cl has been changed. That means here exchange of anions has been taken place. That means here exchange of negatively charged elements have been taken place. So here we can say that this is a double displacement reaction. Okay, why it is a double displacement reaction? First of all, the first key point is that here two reactants are there and two products are there. Okay, and now displacement reaction has two reactant and two product. But now whether it is a single displacement reaction or a double displacement reaction. Now for double displacement, both the reactants should be compound. Okay, now here AgNO3 is also a compound, NaCl is also a compound. Now what will happen here? Exchange of ions will take place, either positively charged or negatively charged. Positive charge will replace the another positively charged element, and negatively charged element will replace the another negatively charged element. This will not happen that positively charged will replace the negatively charged. This will not happen. Positively charged element will only replace the positively charged element only. Negatively charged elements will replace the negatively charged elements only. That means either the exchange of cations will take place or the exchange of anions will take place. So here in this case, AgNO3 plus NaCl, which gives AgCl and NO3, here exchange of anions has taken place where NO3 and Cl has exchanged their position. So that means they have replaced each other. So here exchange of anions has been taken place. So it is a double displacement reaction. Okay, so here you can see first one is the displacement reaction, or single displacement also you can write, and second one is the double displacement. Now for double displacement, don't write displacement reaction only, because double displacement is different and only displacement reaction. Displacement reaction means that is a single displacement reaction is different. Okay, if it is a double displacement reaction, and if you are writing the displacement reaction, then that the examiner will get confused. Okay, so don't write like that. Wherever there is a double displacement reaction, write the full name, double displacement reaction. Okay, and whenever there is a single displacement reaction, you can write it as a single displacement reaction or displacement reaction. Here the reactivity series, as we have seen before, you can revise it. Then comes the CaO plus H2O gives CaOH by 2, and heat is released. Okay, now you will say that here if you will observe, then many of you get confused that reactants are 2 and products are 2. Okay, you get confused like that, that reactants are also 2 and products are also 2, but products are not 2, product is only 1, that is CaOH by 2, and plus heat means heat is released. So that's why I've written plus heat. Plus heat does not represent that here two products are there. It does not represent that. Okay, in the exam this type of questions can ask that CaO plus H2O gives CaOH by 2 plus heat. So heat sign is for the heat released. Okay, it is not the product, it is the heat released while this reaction is going on, heat is released. So as heat is released and heat is there in the product side, so that means it is an exothermic reaction. So what is the definition of exothermic reaction? Whenever heat is released while making the product or while making any kind of reaction, that is an exothermic reaction. And when heat is absorbed to make the reaction, then that is an endothermic reaction, which we have seen earlier. Okay, now here, first of all, so we can say that here on the reactant side, two reactants are present and one product is there. Okay, don't consider that heat as a product, it is heat released. Okay, so here two reactants and one product. So whenever two reactants and one product is there, obviously it is a combination reaction. Okay, because our definition of combination reaction is two reactants and one product. So here we can say that the combination of CaO and H2O gives the CaOH by 2, which is a combination reaction of both. Then comes the C12H22O11. Okay, so this, when it breaks down, okay, when it breaks down into carbon and H2, as I already told you, breaks down means it is a decomposition reaction where the product is, where the reactant is 1 and the product are 2. Okay, so simply by seeing the reaction, you can easily say that which one is the combination, which one is the decomposition, which one is the displacement, which one is the redox reaction, which one is the oxidation, which one is the reduction, which one is the exothermic reaction, which one is the endothermic reaction. So these are very simple. If you know the key points, how to recognize which reaction is there, then you can easily name the reaction. Okay, so here C12H22O11 will break down into 12 carbon and 11 H2O. So here you can see combination reaction, and that heat is for exothermic reaction. And below one is the decomposition reaction. Okay. Now NH3 plus HCl gives NH4Cl. Okay. So here combination of both the reactant gives us the product. So here we can also say that here in this case, combination of both the reactant has taken place and one product have been formed. So here reactants are 2 and product is 1. So here it is a combination reaction. Okay, so this one is the combination reaction where ammonia and hydrochloric acid, they react with each other to form ammonium chloride. So here reactant is 2, product is 1, so it is simply a combination reaction. Then comes the BaCl2 and ZnSO4 gives BaSO4 and ZnCl2. Now here in this case, what happens? Now you can see that 2 are the reactants and 2 are the product. So whenever there are 2 reactants and 2 products, okay, we can simply say it as that whenever there are 2 reactants and 2 products, so it is a displacement reaction. And which displacement? Here compounds are there present in the reactant sides. Both the reactants are compounds, and in the product side both the product are compounds. So in the reactant side also both are compounds. So whenever on the reactant side 2 compounds are present and in the product side 2 compounds are present, newly formed compounds, then it is a double displacement reaction. Now here also exchange of anions have been taken place, that is the negatively charged particles takes place, where Cl2 and SO4 change their position. They exchange with each other. So here you can see a newly formed compound, that is BaSO4 plus ZnCl2 has been formed. So whenever BaCl2 plus ZnSO4 they react with each other, here because of the double displacement reaction, displacement of the anions takes place and we get the product. So here you can see the combination reaction between NH3 and HCl gives NH4Cl. Then BaCl2 plus ZnSO4 gives BaSO4 plus ZnCl2. So here which is a double displacement reaction. Okay, then comes the CuSO4 plus Fe gives FeSO4 plus Cu. Now here in this case, first of all, 2 reactants are there and 2 products are there. So that means it is a displacement reaction. Now whether it is a single displacement reaction or a double displacement reaction. Now for single displacement reaction, on the reactant side, one should be the product and another reactant should be the element. So this example satisfied this condition of one compound and one element on the reactant side. So naturally we can say, and here exchange of now here Fe is a metal, so exchange of metal is taking place. That means Cu, that is the copper, is having less reactivity than iron. That's why iron is taking the place of copper. So here you can see in the reactivity series, iron is present Now you can see below carbon zinc is present, and after zinc iron is present, and copper is present below hydrogen. That means the reactivity of Fe is more than that of copper. That's why here exchange of Fe takes place, or replacement of copper takes place by Fe. So here we are getting FeSO4 and Cu. So here this is a single displacement reaction where only the displacement of the metal or the positively charged particle has been taken place. Then comes the AgCl gives Ag plus Cl2. Now here the reactant is 1 and product is 2. So whenever the reactant is 1 and the product is 2, that means it is a simply a decomposition reaction. Okay, where the breakdown of the compound takes place, AgCl. So AgCl breaks down into Ag and Cl2. So hence we are getting the product Ag and Cl2. So hence it is a decomposition reaction, or a AgCl breaks down into Ag and Cl2. So here you can see that first one is the displacement reaction, or you can also see it is as a single displacement reaction, and next one is the decomposition reaction. Now here you can see Fe2O3 plus thrice-CO gives twice Fe plus thrice-CO. Now here, what are our rules for the reactions? First is the combination. Two reactants are there, one product. No, it does not fit here. Decomposition, where one reactant is there and two product, it is also not fitting here. Then comes the displacement reaction. Now, if you can say that, ma'am, here two two reactants are there and products are also two here. So it will be a displacement reaction, but no. Now here, what happens? See, Fe2O3, it releases the oxygen. Okay, it releases the oxygen, and that oxygen is taken by carbon. So here, that means here simply whenever compound is there and from that compound we are removing the hydrogen or oxygen, whatever. In that case, that means whenever release of oxygen or addition of oxygen, release of hydrogen or addition of hydrogen, release of electrons or addition of electrons takes place. In that case, particular reduction and oxidation reaction takes place. So here you can see that from Fe, oxygen is removed, and Fe we are getting solo in the product side. So as it is removing the oxygen, so by the definition of the reduction, whenever there is a removal of oxygen, then that particular compound or that particular element get reduced. Okay, so here Fe is get reduced in the product side. Then that oxygen is absorbed by the CO, that is the carbon monoxide, and hence we are getting carbon dioxide. That means here addition of oxygen takes place in carbon monoxide, so it is an oxidation reaction. So now here in this particular reaction, both reduction is also taking place and oxidation is also taking place. So whenever in a reaction, when both this reduction and oxidation takes place, then that is a redox reaction. If the reaction is like that, that only the removal of oxidation have been taken place, but not addition of oxygen, then that might we have called it as a reduction reaction. But here both release of oxygen and absorption of oxygen is taking place. So here it is both the reduction and oxidation. So we can combinely call it as a redox reaction. Again, removal of oxygen you can see here from CuO. Okay, and we are getting the product Cu and H2O. Why H2O? Because H2 is absorbing the oxygen which is released by Cu. So here addition of oxygen and removal of oxygen is taking place. So when both the things happen in one reaction, then it is a redox reaction. Then again comes the in the Fe3O4 and H2. When these both react with each other, then what happens? Oxygen is released and it is absorbed by hydrogen. So both the reduction is also taking place and oxidation is also taking place. That means both removal of oxygen and addition of oxygen is taking place. So it is a redox reaction. Okay, I hope you have understood about this, all the reactions, how to name the reactions. Okay, so now let's evaluate. Now tell me, what do you mean by the rancidity? What do you mean by the rancidity? Yes, those who know, unmute yourself. Now here rancidity means, so when we use the old leftover cooking oil for making food stuff, it is found to have a foul odor known as rancidity. So if food is cooked in such oil, it taste changes. So when this leftover food is placed for a longer time, or the fried food is placed for a longer time, then it undergoes some kind of oxidation or hydrolytic rancidity, or it can be a microbial reaction. So because of which it causes rancidity. Okay. Now tell me, what do you mean by the let's revise some of the definition of the reaction that will be helpful for you. So tell me the definition of combination reaction. Yes, Anjali, unmute yourself. Anjali, unmute yourself. Okay. Then Priyanka Sonar, unmute yourself and tell me the answer. Priyanka Sonar, yes, tell me.
Yes, when four more reactors combine in a reaction to form a single product, it is called a combination reaction.
I can't hear you, Priyanka. I think network
Yes,
issue.
ma'am.
Yes, Anjali, tell me.
Ma'am, can I tell the definition of combination reaction?
Yes, yes,
Teacher,
yes, yes, tell.
when two or more reactant combined in a reaction to form a single product, it is called a combination reaction.
Very good. Now then comes the decomposition reaction. Yes,
Ma'am, can I?
yes, Trupti, tell.
The chemical reaction in which two or more products are formed
Hmm.
form a single reaction is called decomposition reaction.
Yes, very good. Then tell me the definition of displacement reaction. Yes, Yash, unmute yourself. Okay, then Ruchika, unmute yourself and tell me the answer. Ruchika,
Yes. The reaction in which the place of the ions of the less reactive element in the compound is taken by the another more reactive element by formation of its own ion is called displacement reaction.
okay, so here in this case, definition should be that whenever a less reactive element is displaced by a highly reactive element, so here in this case, it is a displacement reaction where replacement of the ions takes place. Okay, the displacement or a double displacement. Okay, so I hope you have understood the topic. So here we have finished with the topic of chemical reactions and equations. So I thank you all my dear students, teachers, and BMC Education Department for giving me this opportunity. And thank you all. And, that's all. Thank you. Have a nice day.